Hey, I'm NeoGoose by the way, and last time I've been doing 200 lines of code, HTTP web server in assembly. Somebody tweeted me, what's next, React? And I thought, why not? So there is a new specification by React working group called React Server Components, which I was interested to learn. So I decided to reverse engineer it by re-implementing them in assembly. And here's what I have. So here is my web page. You can see it works. And what it does, it streams information from my file in an interesting way. So if I will put something in here, right? And then something here. Guess what will happen? You will see everything will be broken because of the HTML stuff. But it actually fine because we can do this like that, right? We can probably wrap it like this and it still works, magic. And it does it through the React server-side rendering server components, which is totally different. So today I'm gonna show you how it works, abstracting from all of the React implementation, all of the React code, just the way this protocol works. We'll describe you what might be useful and then show you my little bit of my assembly. And my assembly is kind of nice because it's 421 lines of code. It's everything you need to run it on macOS. It's macOS assembly with usage of libc, which is included into your SDK, and it's okay. And what's fun, that if we're going to the package lock JSON, basically my assembly implementation of React Server Components is 10 times less text than a single package lock file for a Node.js project. Isn't it fun? Isn't it fun, right? So let me show you how it works. So firstly, we need to understand how we used to work with the data in a browser, right? So we used to do something like that. Okay, so here should be JSON, right? So we used to do something like that. Browser sends request to the backend, which is returning some JSON data, which is then somehow processed by double React, okay? And then it's creating some VDOM, rendering things on HTML, and all of the things, right? Kind of used SPA way. Good or bad? Not a question right now. So what is this new specification means? It is not rendering on HTML. Surprise, React Server Components doesn't work without JavaScript. You need JavaScript to render the thing. So what they want to do is they want to actually change this JSON part. They want to use React Server Components payload here, which is then sent to React, which is then can do something like that. It can either render a usual VDOM with client components, with state and all this thing, or it can render HTML directly, which means that it is bypassing all of this VDOM creation, all of this JavaScript payload. We know that React is not that fast, and it renders basically HTML directly when it's possible, and when you need a state, it renders it through the VDOM, which is kind of fun. So how does it work? So let's get back to this file, and I'll show you how it works. So basically, all of the React Server components is still using good old XHR request with a payload that looks something like that. It's actually easier to inspect them in curl. So basically it looks something like that. So you can see that it's basically some kind of JSON, which is not JSON. It's actually text with links to the JSON. So it's chunks and lines of text, which can be linked together. I'll show you later. And it says basically we want to render pre-element, which is saving this, white spaces stuff, which is this element, with the children of span from my file. Then we start strike through children. I will post something in here. Then we have span, and then we have /n and something. And basically that's it. So how is it rendered? So here is the actual implementation that is coming from the React working group, is an official demo. I didn't write this code, so no questions to me. So how do they do this? So they create this render tree from fetch. So they have this fetch, which is my, you can see this is my endpoint, my assembly endpoint that returns this tree. Then it stores into the map, which is in a state, mutate this map somehow, okay, which is then basically passed to the use hook or whatever use function, and it's this use function already transferred all of the things into the working React tree by either rendering client-side components. How we can do this? Let's do a ref, this file, and you can see that now the server side, the client side component rendered. How do we know that this is client side component? Let's check. So this is a client side component because it has a state. So here is a state 0. You can do things like that. And it's not possible to render on the server, right? Because server components are always stateless and they are always basically HTML. They are always transferred to HTML and your client always receiving this kind of HTML when we're talking about server components. And if you want a client components, it will receive what it will receive. Let's check. It will receive this kind of stuff, right? So this kind of stuff is React server components like thing, which is in this case, what it says that we have a component called pp alert that is coming from the chunk main of the default export. And then what we need to render this 0 of without this I, meaning that we need to render this component from the line 1, here one, with the props error code too. And then React will basically do the same thing that you do usually manually by importing the pp alert and transferring this error code automatically, deserializing this and passing the props. So you can see that this is just a normal client-side component. Why it might be interesting. Let's say you want to build some kind of command system like GitHub is doing in React. And you want to do it in a more or less smart way. So you don't just support Markdown, support transferred in HTML, but you also support some kind of interactive component. So you can hover over your link and has a nice preview with a nice little thing. So what you can do with the thing is you can, instead of given the markdown data to your clients, parse it on the front end, create HTML from this data in client, in your React code, and then having a lot of performance troubles because React is pretty slow. You can do the thing. You can just return a set of HTML elements, which will be transferred on your server in Node.js or in assembly, whatever, why not, right? And that whenever you need this little interaction, you can render, like instead of here, I render strike through, but you can easily render this pp alert and have a children of pp alert here. So then you will have this little interactions coming from the server directly without additional incrementation, like without additional like suffering in the server, using the same technology everywhere. So I kind of see where it might be useful. And I even like the idea. The only problem that you can see here is that it is kind of proprietary structure. It is not open standard. So like, don't try to use it from the different languages, even though it might be used. It might be easy. So it has this dependency on the bundler. So you can see here, the pp alert comes from the chunk main and name default. Where it does get this information, it is coming from the manifest. Let me show you. So in the build folder, there is manifest, which gives information about the client component. Here is the pp alert.js in a chunk main, and then there is also this pp alert, and then there are like default specifier with a name default. So your bundler needs to give this information to your server, which now knows a set of your components and can send this information, mixing it with basically replaced HTML to be then created by React. Okay, interesting. Makes some kind of sense. But I'm genuinely happy that I have this working in assembly. Please don't be scared about assembly. Please don't be scared about assembly. Assembly is really easy. If you have never been writing a single assembly code, I have a 20 minutes video about using HTTP web server, about building HTTP web server in under 200 lines of code in assembly, which super detailed. It will walk you through everything you need to know about, like how to create an actual HTTP server, and this is built on top of that code. So if you're interested in how the actual socket and network instance works, watch this video. And now we will quickly go through this code. So basically the idea, what I did, I basically checked what the JavaScript code returns and then basically re-implemented it in assembly, which is kind of straightforward. So basically I have this response start, which is always start with a prayer, with the children of a span, with the children of whatever goes next, right? And then we end this sequence by closing all of these things with colon children, closing this children, pre elements and stuff with all of the replaced logic, which is very hard to see. I understand, but nothing is really complicated. So if we're going back and checking the curl here, you will see that this is part that we have a start thing, and then this is the part that we end it with, right? And then everything that it goes between is generated based on the file content. I will show you how it works, so let's jump to the main thing, right? And here you can see that I have a lot of networking code here, which is, again, I descriptively described in a previous video, so I will skip it a little bit. Basically, just creates socket, bind the socket, creates address, fills the HTTP port, logs all the things, and then inside request loop, it accepts the connection, then it checking errors, reading the request, doing some navigation, because you can see that we are requiring RSC, and if you will require something else, there will be nothing. It's not needed, but it's fun that it's here. And now we are entering the serve RSC, which is fun. So first of all, in serve RSC, we have this header, which we need to send. Obviously, it's okay. Then we send in the server myAssembly and the content type text X component, which is something you can see if you will go here. You will see that in the headers, you have this text component in myAssembly stuff. Is it required or not? I am not sure, but so next we do the actual file open stuff. So firstly, we open the file from the path, which is hard-coded as read-only file, right? It is syscall_5. Nothing really complicated, just calling a syscall, and now we have a file descriptor, basically pointer to the file into x0. So we save it into x20, print in some debug message, and then if the x20, if the file descriptor is less than 3, which usually means that file descriptor 2 means nothing, no directory, we need to send the file error, right? So if I will basically remove the file, you've seen this UI already. So yeah, let me show you. Let me show you one more time. Let me show you. I will remove it, right? So now we removed it, and you can see that it sends error code 3. So if we will get back to curl, you will see that it's Pepe alert, error code 2. This error code is basically this x20 right now. This is what our file system returned to us. So what we do, we pull it into the x0, and now we call in the asprintf function, which takes the buffer it needs to fill, which is 10p buffer that is just allocated. Why it is 2 times bigger than file buffer, because we need to escape all of the thing. It's just like additional space for safety, right? So the file buffer, so we have this file error, right? And it fills this file error tree, which is basically this thing, right? But it has %d here, meaning that the x0, which is filled now with the status code or whatever, like file descriptor or error code, will be put into. And now we call in the sprintf function and basically getting back the length of the new buffer, right? Because it can modify the buffer because it replaced something. It returns back you a new length of the buffer, which you can use to write this 10p buffer to socket. So we just pull it into x2, and then we call in syscall number 4, which send this 10p buffer to the client, and then we close the connection. And then you see this beautiful UI. Great, isn't it? Okay, so now let's go to the actual file read. So here you can see that we validated the error. Now we're writing the response start to the client. So technically, this works as a streaming. So it's too fast to stream, but technically you will firstly see this pre-element go in first, and then you will see all the content fill in later. So we firstly write in the socket to the, so we're firstly writing this response start, which is pre with the children living open. Then we do some debugging stuff. Now we do reading the file. So we read the file, we know that it's open, we know that it will be read, it's totally fine. So we read it into the file buffer. Now we store the null terminator in the file buffer because it's just the way it needs to be done. Or maybe we can skip it, but it's okay. So we have this null terminator. And now we close in the file after some debug message. If the file is empty, right? So if there is nothing to, if like there was nothing to read, we basically go in and send in the close message, which means that it will be basically empty string. I can probably show you. So there is nothing, right? Now let's save it, and you can see there is nothing in here. There is no error. Now we do this file buffer escape in, right? Before you can write something like weird here, you can do some backslashes, you can do something like that, you can do, no, you can do something like that, you can do all of the weird, yeah, like empty lines. And I want it to be like totally represented in here. And you can see that it's totally representative and it needs to be encoded, right? So in case of curl stuff, you will see that there are a lot of backslashes everywhere that are needed and like backslash ends instead of actual new lines, which is nice and which is usable. So we need to somehow implement it. And I implemented it by not using JSON escape function. I implemented it by hand because everyone was hating me that I used libc too much. So I implemented it myself for your education. Please appreciate. So I have this function, which is basically escaping function, which takes x0 as an input buffer pointer, x1 output buffer pointer, and x2 as an input length. So what we need to do is we need to take information from input buffer, pull it into output buffer, and modify the input length accordingly, right? It's easy. So here is a flag that we need to check if we open the double asterisk encoding or we close it. Let me again edit it a little bit. So I will do this thing. I will wrap it in the double asterisk for understanding how it works. And we will go and open it up. So you can see that we inject this little span, and then we close the span, open the strike through. Now we have the children of strike through, everything that is inside the strike through. Then we close the span and basically continue to close the strong and the strike through and continue with the span, the new span. So how it works. So we go into the loop, which gets the next character. If there is no character, we're done. Then it checks if we have two asterisks one by one. So checking the current asterisk and the next character. So if they both asterisks, we go into the open strong or close strong, right? So in this CMP3, we are checking that this flag basically equals 0. Otherwise, like we choosing which one we will be executing right now. So these functions are basically same. They are basically same. So we either insert this closing the current span and open the strike through, leaving children open, or closing the current children and then opening the next span. So in this close strong implementation is fairly simple. So what you need to do is you need to copy this strong close or the span close stuff into the new string, right? So I have this function copy string, which is not really the best and the most efficient, but it works. So what it does, it basically loops one by one and like converting characters from one pointer to another one by using the offset. And basically on done, it just returns back to this line. And then it needs to store, it needs to modify the original pointer by 2 because we skip both asterisks in the current iteration. Then we do strong close length. We need to modify the new length. So we need to know exactly how much bytes we have like meaningful in this buffer to send them on the front end, and it won't be filled with all of the weird characters, because if we will do it like that, it will be just broken all the time, right? Which is not what we want for sure. Or it will be even crash because it will be something like totally unreadable bytes. So in this case, what we do, we firstly load this strong lines into the register x5 and then reduce in 3. Why? Because we already have this 2 asterisks included and then an null terminator. So we just reducing it by 3 and then increasing the new lengths by this new value, right? And this happens with escape open strong as well, right? So it is like the easy way of manipulating this stuff. And in case they're not asterisks, we do the very simple thing. So we just escape code \n. Why did they put a \r here? It makes no sense. It's just macOS ARM assembly, whatever. So we just do this 4 functions. So we firstly store in the / on the new buffer, then we store in the actual character on the new buffer as well. Then we increase in the both pointers by 1 and 2. So original pointer goes by 1, the new pointer goes by 2. And the length is increased by 1 because original length included 1 character, and now we have 2, so we increase it by 1, and then we're going back to the loop. And that's it, right? And that's it. And this allows to replace and JSON encode and escape all of the things, right? It's pretty like, wordy, but at the same time, there is nothing like, there is no rocket science in here. And the fun fact how it works, I really love it. I especially love this UI, right? So yeah, I mean, generally saying, it was really fun to do this little experiment, learn a little bit about this React server component. So now I know, and hope you know the way they work and how you can try to use them if you by any chance use React. And if you like this kind of breakdowns, if you like how I talk and assembly, please let me know. You know how to let me know. Subscribe, follow, GitHub sponsorship, stars on all of my repositories, comment, all of this stuff. It would be super helpful to understand should I do something like that, because I have a bunch of ideas. Like, for example, I have a few microcontrollers. Yeah, and what would be fun is to program this microcontroller with a real display in pure assembly, in pure RISC-V assembly. I have a banger idea project, but I need to know if somebody will be interested in it. Okay, thank you so much for watching me. Have a nice year, and bye.